Welcome everyone to the 2024 Electric Vehicle Formula SAE Public Design Review. I'm one of your two design co-captains this year, Bill Riley. Also with me is Chris Patton, who you'll be seeing later. First, I want to just give a quick introduction to say it's good to be all back with you. It's my first electric vehicle competition after a few years. I think the last one I was attending was at Lincoln, Nebraska. So to see the improvements across the field is really incredible. And the other design judges who were here from last year said that even in the last 1 year, we've seen a lot of incredible improvements. So congrats to all of you for all the advancements and improvements you've made. Tonight we'll have three essential elements to our presentation. We'll talk first about the top three design finalists, and we'll go in third, second, first order. Then we'll cover some general design information about the process and what we look for in the designs. And then we'll finish up with a question and answer session with a few of the design judges who are in attendance tonight. So that'll be the general order of events. We're going to start off with the finalists then, and we will be announcing as we go through the slides. So our third place finisher for Formula SAE EV design this year is car number 250, Michigan. As you can see, it came in at about 193 kilos with a very good 50-50-ish weight distribution. It had 4 hub-mounted motors using the MK DD5s. The pack, the as-tested energy was about 6.1 kilowatt hours. They were running the 10-inch Hoosiers. It was a full composite monocoque, and they had front and rear wings plus side pod under tray. Some of the comments we had about it, we're just kind of doing high level, and as you all hopefully know, the cars are outside the tent, so as we wrap up this presentation, you can go see the cars and think about some of the feedback we had and see what else you think about them. But the Michigan car, we noticed that the front and rear wings were very stiff vertically. They did have some lateral compliance that we thought could be designed out. The rear pushrod angles were a bit suspicious, so I didn't personally deep dive that, but they looked a little bit suspicious. The high voltage leads were also longer than they needed to be, so we were just, why do you have all this extra copper and plastic that you don't necessarily have to have? Same for the cooling lines. They weren't necessarily tidy and as short as possible. Other teams we did see had aluminum lines. Generally, the aluminum will be lighter, so you can use aluminum and then transition to flexible rubber or where you have to for the geometry. But it's making sure, it doesn't have to be a one solution for everything that might be heavier. But all in all, the Michigan car looked really great. We were happy to talk to them and have them here, and they're third place this year. Let's give them a round of applause. And our second place design finalist is Montreal car 238. Montreal came in at 207 kilograms with a 2-wheel drive with an MRAX in the back. Their pack, as tested, came in around 7 kilowatt hours. They also had the 10-inch Hoosiers running the R20 compound. And this was a tubular space frame. So it just shows there's not as always, we say up here, there's not one solution that's a design finalist. It's how you put the whole package and systems integration together. They also had front and rear wings and an under tray. In terms of some of the visible design feedback, you could note when you check out the car, they had front pushrod threaded adjusters that we thought was in a sensible location, far from the end. We see a lot of, at the far end. We see a lot of cars with the adjusters in the middle of the link, which is always, interesting because you have more moment there. You also have it's basically a two-force member if you do it right, but there's also vibration loads and all these other factors when you think about it. So we always like to put the adjusters at one end or the other. We think that's just a better way, and this is how Montreal did it here. They did have the threaded adjusters. Some of the things like push rods, toe, you can put the shims so that you have more repeatability, just as a note. The wings and the bodywork were all very stiff and solid. The rear pushrod attachment was unusual. It's worth looking at. Normally we would maybe bring the upright out to the points where the links are coming in. They had sort of a secondary structural feature to go from the upright to where the link geometry was. And they had a drag reduction system on the rear wing. But let's give Montreal, our second place design finisher, a round of applause. And in first place, we have McGill, car number 233. The McGill car is a great looking car, I have to say. It came in at 195 kilos with a 46% front weight distribution. It's four-wheel drive with the hub-mounted AMK motors. 7 kilowatt hour as tested pack, which was air cooled. They also ran the 10-inch Hoosiers on the R20. It was a full composite monocoque, and it did have front rear wings and an under tray. Again, it was a really pretty car. The front wing was impressively stiff and well mounted. I think it's definitely worth looking at. And I think one of the takeaways is that you can do the struts more like A-arms and such on the wings, but a lot of these mounting configurations that we think likely lead to giving the chance of wing to work and make downforce tend to be more structurally mounted, just as a data point. They did, during final design, they did mention that they had decided what spares to bring based on a risk assessment, which was interesting. The front suspension link ends had an unusual design. Essentially, the tube necked down to two kind of parallel flanges that we thought would introduce a weak link in the design. The tub, where the link came in where I was describing, the tub side of that same connection was very tidy, very compact, and really worth checking out to see how nicely they did that feature. The side pod tray and the rear wing were also very stiff and well mounted. The cockpit rim on monocoques is a very important feature, and there's many different ways to make the cockpit rim effective. But when you think about a tub, think of it as like an open shoebox, and it wants to deflect when you torque it and have all these different deflection modes. So the cockpit rim is something we generally look at pretty carefully to make sure you're doing all the right things there. And they mentioned they had extra unidirectional plies in that cockpit rim, which is a really good move to get more stiffness around that opening. But we thought here there was a missed opportunity to also have a bit of a return flange and get nice big geometric cross section there for higher moment of inertia. So, using all the tricks in the book, they had some of the tricks, but there was some that were still not in play. And then I'll just finish with, I think that of the cars I looked at, it was one of the nicest for the high voltage, low voltage switches and the different connector points. It was just very tidy, integrated with the tub, and it looked like a very low mass. I could walk up and understand all of the functionality, so definitely worth checking out when you walk down the cars. But let's give car number 233, McGill, a round of applause for first place design finish. All right, with that, we'll transition into some of our design considerations. So we have kind of a more succinct version this year, try to spend some time with Q&A. And so in terms of general approaches for design, it's really important to think about this cycle, this taking the theory, doing your design, doing analysis and refinement of that, building it, testing it and validating your design, and then going back through the loop over and over. And that loop might be year to year, or it might be within a year. But when you come to design and talk to us, we're really looking for this evolution of the design from the first concepts, your analysis, building it, testing it. And so that is, you'll see that in the score sheet if you look at it, that we're looking for those different elements. And we really wanted to start out our talk tonight on the design approach with that. And going through that cycle is a really good way to get designs to improve. In terms of vehicle architecture, the vehicle layout should be a part of your rigorous engineering process. I was asking questions in final design that were focused on things like how you made decisions. And we weren't looking for one decision or the other. For example, hub motors or a central inboard motor. We just wanted to understand that you knew the trade-offs in that. So if you had to pick the inboard MRAX motor because that's what you had and you had a combustion car last year, we just want to know if you understood the pros and cons of that. For example, is your lap time going to be faster or slower? Is your mass heavier or lighter? So it's not that the decision itself that's important, it's that you've understood the pros and cons that went with it. Load paths are very fundamental to the vehicle architecture, as is the mass distribution. So in the first month of working on the car, you've made a lot of fundamental decisions that'll impact your overall design and vehicle dynamics. So it's really important to get those things right, thinking about CG location. And for every other part of the car, the load cases that go into those parts, obviously, all the parts need to not break, and so what are the loads acting on them? What are the boundary conditions? Obviously, the car interacts with the ground at 4 points, which is your contact patch. So that's a really smart place to start. What are the failure modes? We have tension failure modes, compressive failure modes, either strength or buckling, shear, interlaminar failure modes, and composites. There's lots of ways the car can break. It's trying to break on you. We want to make sure you're on top of that and you're working to thwart those failure modes. Also, we love cross sections. We love free body diagrams. These are sort of the language of engineering. They're the language of design at Formula SAE. So always great to have cross sections, free body diagrams, so we can work through. I think some of our final design questions even included free body diagrams or moment diagrams. And then lastly, documentation. It's a way you can also use to communicate and run your team. It's also helpful for talking to us in design. Things like setup sheets, checklists, wiring diagrams. These make the team work better, and they help you communicate to us in design what your intent and your as-built configuration is. Talking a little bit more about vehicle mass, because it's so fundamental, we call it a first-order effect on vehicle performance. So we spend a lot of time talking about the weight of the car, how heavy things are, because it's so fundamental to how the car works and behaves. And so hopefully that's pretty obvious. But we also want to take a holistic approach to weight reduction. So, we say the best part is no part. So every part has to earn its way onto the car. Make sure that the performance or the advantage it's giving you is worth the weight, the cost, the effort. The human effort is a big part of it, obviously. Also trading off between purchase parts and in-house built parts, all of those things. For legacy designs, we don't worry too much about it, where this part came from, or the history doesn't really matter. We need the people we're talking to that year to understand where they came from and be able to speak to them with full knowledge. So just keep that in mind. If you have parts that you've inherited, worry less about that and worry more about your understanding of why they are the way they are and how they all work together with the car as a whole. The driver interface. You need to make the driver's life as good as possible so they can do their job and get a fast track time. So we look for things like supportive seats, easy access to pedals and shifter, low steering compliance so they have confidence in the car. All these things are very fundamental. And then lastly, we talk a lot, I'll just kind of generally use the word tidiness to mean things like threads. You have 2 threads past the nylon, the lock nut. You don't have 8 threads. You don't have things that are longer than they need to be. Wiring is tidy, generally co-located, out of eyesight if possible. Plumbing is as long as it needs to be and not longer. You've already heard me talk about that as some of the feedback on the cars. So these are very fundamental things you should be looking at, along the way as you're designing the car, and keep checking back in it, because I think, as we all know, entropy sort of drives the cars to look a little worse every day as we work on them. In terms of general design process, where is your starting point? We think the rules The tires, the scoring, and lessons learned from last year are no-brainer places to start to think about what you're going to be doing next year. And think about it on a per event basis. So it's like skid pad's quite different than acceleration, and you want to be maximizing the ability of the car to work to your own sort of set of system requirements. So what performance specs will meet the goal? You're setting those all out. We try to meet you wherever you are with those. If you say we just want a car to finish endurance, we're happy to judge you to that. We need to know what you're thinking and how you plan to run the team. We expect you to break the car down into systems and work down, but you need to keep coming back up to the integrated vehicle level and make sure the car works as a whole, and that you don't have 5 subsystems that are super optimized but don't work well together. And that's easier said than done, I know, but you need to work towards that goal. And then weight distribution and CG, they're more than a spec. We say it again coming up, but you have to be really methodical and be careful on how you manage the weight of the car and iterate through these issues to get good outcomes. I will say one last thing is we can walk up to a car and we can sometimes tell when team members aren't talking, when the chassis and the suspension folks aren't talking, and the points are way out in space. So you need to have tight communication between team members who have neighboring systems. In terms of other considerations, these are some general things to keep in mind, and there's no right or wrong answer to these. So we have like the keep it simple, stupid versus high-tech approach. The tire data is super important, but it's all available through the Tire Test Consortium, which hopefully everyone's aware of. Data acquisition, it's both an engineering tool and a driver tool, and so it's really a lost opportunity if you're not making full use of that. I've talked already about mass a few times, but there's the kind of conflicting requirement of stiffness, so balancing stiffness and weight to get the parts to work well. Single inboard motor versus hub motors, these are architecture trades. Again, we said there's no right or wrong answer. We just want to understand how you chose and why, and that you understand the pros and cons. Itty-bitty parts, basically, if it's too small, it breaks, so you need to spend the mass you have in the right place to get a good outcome. Materials, again, carbon fiber can be cool, but it's not required to be a design finalist. We have a space frame car here today. So we're just looking to understand the trade-offs and how you got to the answers you did. And then finishing up with physical testing, everything's good on paper in the model, but we want to see the track data, the component testing, or dyno testing for the powertrain, all these different things help build the story of how you got to the car you did. So we're going to deep dive just a few of these things quickly, but here's a slide showing design complexity. So this is an older Australian car with the suspension, and we have this other very simple pushrod suspension. Both of these systems keep the car from dragging on the ground, but they have a lot of different design inputs. They take different amounts of your time. They have different costs and complexity. So either are great answers. We just need to understand how you got there and show us with analysis data, lap times, all these different items. In terms of aerodynamics, it's like it takes time and effort to build wings. They have weight, they can break, but they make a lot of downforce. So whatever you decide, whether you have wings and under tray or not, we just want to see that you compared and contrasted those options and that the ones you decided on make logical sense for your vehicle. So if you say reliability is number one, we want to finish endurance, but we have this super fancy wing system that seems, to be in conflict. So we want to make sure the car is designed holistically and in sync with itself. Again, for composites, space frames, monocoques, they're all good. You just have to trade and show us why you picked what you did, again, in all these same metrics. In May, there was, just as a fun fact, there was 50% of the cars were monocoques and 50% were space frames. So there continues to not be like the right answer, the answer you have to give us to be a design finalist. And here's some kind of rules in quotes here because they're more guidelines. But good design, if you walk up to it and it looks sensible and it looks right, it might be right. And if you walk up to it and it just looks wrong and the load paths are bad, it's probably a bad design. And so there is this kind of gut level check you can do when you've looked at enough of these cars to see if you're going in the right direction. Good load paths are your friends. Triangles are also really the key for space frames or tetrahedrons since we're building three-dimensional structures. The best part is no part. So again, I said every part has to earn its way on the car. If it's there, it should be for a reason. You're not just putting it on because someone did all the work, but it's weighing it down. Really practicing systems engineering, having that tight communication between the team members. No engines at the EV event. And then last saying, mass begets mass. So just think if you add extra mass to your accumulator, now the car mass goes up. Then because the loads, they say a 3G bump is a fixed amount of load, now the push rod, all the suspension linkages go up. So you have to really drive mass out of the system because a little bit of mass on the sprung mass will just drive mass into everything. All right, and then a few things to ask during different phases of the project. Does the car look like it was designed with a systems focus? That's things like, are the suspension points near frame nodes or the tub? Are the wires going in a sensible direction? Are there 5 connectors outboard at the upright where there could have been 1? These things are just very simple things to check. And at the last minute, it's very easy to put another connector in there, but they're all things that catch our eye. What parts look like afterthoughts, and were they? Is the packaging tidy and look like it was planned? Are items such as wiring exposed or neatly routed in looms? Are components adequately protected from the environment? Things like brake lines that are in front of the arm, they can catch cones and be a problem, or you put them on the back tube away where they're shielded. This may make a few grams of difference or none at all, and just having a thoughtful minute to make it look tidy and sensible is really the key here. Is the car reasonable to maintain and adjust, or is it a nightmare? Is the car on track to hit its mass? We look at your design spec sheets and the as presented masses to see how well you did on sort of tracking to your targets. And tuning, can discrete adjustments be made? We were talking about threaded adjusters versus shim adjusters. So are you putting the right components in the right areas to make the car tunable and adjustable? Because your practice time is limited and maximizing that is pretty smart. Here's a few more packaging examples. So these do not look clean, not well thought out. They're asking for trouble. Essentially, the cars that have the least thought, they look like they have the most stuff going on. They look busy, they look messy. The cars that have the most thought, people have labored over and struggled with just fixing it and making it clean and beautiful. This is where the upfront work pays off. And when you walk up, you're like, well, there's nothing to these cars. They're pretty straightforward. I don't even know why this is so hard. So how hard it looks is sort of inversely proportional to how hard you do work, we think. Be tidy with details, wheel studs that are sticking out, lug nuts that are too long, all these things, they leave an impression that you haven't, just having a maniacal sense of detail and caring about every gram is really essential, because if you're cavalier about grams on your wheel studs, then are the other details right and excellent? This is what goes through our head. Aero devices, obviously the aero devices need to work aerodynamically, but there are also structures that need to be designed to be stiff and effective so they make the right amount of downforce. And so making sure that you're sizing those laminates, even if it's one ply, understanding how thick that ply should be, what's the cure ply thickness and why, and how is the skin integrated with the structure of the wing. All these things go together to make the wings work or not. And we often see wings that have hours poured into picking the airfoil, but not hours poured into making the laminate sensible to carry the loads on it. So we really encourage you to treat wings like other structures on the car, to develop load cases to make sure they're going to work. All right, that finishes the formal design review part and feedback for our second agenda item. Next, we'll be doing a question and answer with some of our judges, and Chris Patton will be coming up to run us through that.
All right, so if you guys have any questions, I would... All right, if you guys have any questions, I'd say line up over here and we'll just take you through. We'll give you the mic, you can ask the questions, and our panel will answer. We'll take any takers.
1, 2. Um, what are your thoughts on decoupled roll heave suspension versus corner dampers?
So the coupled roll heave suspensions, they tend to add a lot of structure and complexity, and that can be an okay thing if you can justify its use. But there are a lot of really good looking, just direct acting shocks. So it does seem like it's very popular right now to have these decoupled roll heave shocks and springs. I certainly don't think it's necessary. I think you can make a very fast car without them. But like anything else, you need to understand your goals and justify one design over the other.
Hey, I'm kind of the noise Nazi in the building. If you don't want to be in here, that's fine, but don't be in here making noise so other people can hear the answers and the questions, okay? It's only kind to do that. You'd want the same respect if you were standing here. Did you catch me way in the back?
I was just kind of wondering, for design itself, it seems like different judges have different styles of presentation that they prefer. Some like a short, concise kind of initial presentation, and then they'll ask questions. Some like an entire story. So I guess how would you guys say to possibly deal with those differences, or to maybe even pick up on them quickly so then you can possibly lean into that style more, so then you can give a better overall presentation for the judges in design?
Yeah, this is a very good point. We have a large group of judges, and we all have our own unique views. And so you basically need to be prepared for anything. I know our philosophy was that we could walk in and give a presentation, and we could talk for the whole time about the things that we were interested in talking about. As a student, As a student, you should be prepared to just talk the whole time about the main things that you're interested in, from your goals, and then how that goes down to every subsystem in your car. We as judges will have our specific things that we're looking at, and it's going to be different for every judge, and you're just going to have to roll with that as we ask questions. So you really have to be prepared for a very wide range of questions.
I will add one quick thing, which is when you come into preliminary design, we are expecting you to do about a 2-minute introduction to the car. This is true across all design cues and not personal judge preference. So come in with a 2-minute kind of story and tell us the key things, then be prepared to tell us this by subject matter who's who, and we'll kind of pair off. And then from there, all the great advice Chris gave you completely applies.
Yeah, thanks guys. Could you talk to maybe like quantitatively or qualitatively trading performance and reliability, for like a system architecture?
Yeah.
You're asking, so I think the thing we're looking for is for you to define that and do the work. And we're open to anything. I think hopefully you took away from our talk that there's not a right answer. Although I think we all agree the wrong answer is braking during endurance. So if you're saying we're going to not brake in endurance, then we can have a conversation and tell us, are you holding a safety factor of 4, of 2, of you want to design it for the weekend autocrosser to do 10 autocrosses a year. We're open to whatever you guys set out, and you show us that to be true. But we really just, you should be expecting to present, potentially if asked, on how the car is expected to survive at least one FSAE competition.
This is kind of similar to the previous question, I guess, but our team just passed tech for like the first time in 7 years, and it was like really exciting. But at the same time, we're kind of struggling to learn how to balance like risk mitigation of like, okay, we have a car that works. We know there's all these things we need to fix. Like, it's not a great car, but it works. We want to fix a lot of things, but we also want a running car next year, and we don't want to take steps that are too big and sort of, fail again. So how do we balance that, and how do we justify those design choices to the judges?
All right, I'm going to go back to the best part is no part. So I would say don't go biting off more complexity. You need to, like in the old days of Formula SAE, we had about a 40% pass rate on endurance. I don't know where we are today. But so it's really like passing tech, step one, finishing all dynamic events should be step two. So it's like don't, bite off more than you think you can accomplish with that as sort of the criteria would be my advice if you're trying to maximize points. If you want to go after design, you might take a different approach, but that seems like a pretty sensible place to start.
And it goes back to your goals as a team. Like, what are you trying to achieve? And if your goal is to win competition next year, and you don't think you can do that with your current architecture, you're going to need to change the architecture. But if you have a more modest goal, it might make a lot more sense to have a very stable architecture, make minimal changes, and just do a lot of refinement, and then kind of go back and forth between like an evolution and a revolution of a car.
One more quick thing, which is say you don't have wings right now, but you could say get more points on design for aero by analyzing some wings, spend a couple days doing analysis and hand calcs, and come in and say, look, we don't have wings because we don't have the bandwidth to make them, and we know we give up X seconds in endurance and X seconds in autocross. And so without adding more bits to the car, you can still go after more design points by sort of doing work on those alternative designs and being prepared to speak to them.
During design and after, we've had judges tell us that cost is not a valid design consideration. I was wondering if you could expand upon that a bit more.
I would be surprised to hear a judge say that.
Yeah, we've had judges either straight up tell us that cost is not valid during design, we shouldn't include it, or inferred it in other ways.
I think there can be some nuance to that. Like, do you look strictly at the event cost, and how that relates to the overall competition? And you should definitely balance that. Then there is the actual, the cost that the team has to spend, the dollars that you have to spend. And I don't know how you do this competition without considering both of those. So I think you should consider both of those.
I mean, I would also say that every practicing engineer likely has to worry about cost in real life, whether you're Formula One, who have limits on budget, or Formula SAE, or whether you're an automotive OEM. So I think that, we might even make a note about this in our design judge training next year, but I think that cost is certainly a valid component, just like human bandwidth, how big your team size is, how many people you have. And hopefully this comes full circle again, at the risk of being repetitive, which is, it's like okay not to have wings because you don't have the people to do it. We just want to know that you looked at wings and you understand the trade-off there. So I think cost goes with that. Say we don't have money for hub motors, so we did this other thing, but we know how much it cost us in acceleration, and here's why. And I think if you use that rationale, that should work with the judges.
One more thing to add, that sometimes you do need to go out and find more money. Like, often it's just a fundraising issue, and each team needs to decide whether that's something they want to prioritize. Do you want to put your time into going out, talking to companies, trying to get sponsorships, working with the university? So like everything else, that's a trade-off that your team needs to decide.
Thank you.
Hey, could you speak a little bit to the creativity category and maybe some interesting design choices that teams have had that have scored points on that?
So generally, we don't give a lot of points for creativity. Usually it's something that we've never seen before, and often we expect there will be a rule because of it. I'm trying to think of any specific examples. Yeah, I'm even struggling to come up with an example. I'm sorry.
Okay, thank you.
Yeah, it's very hard to get creativity points. All right. Thank you very much.
everybody. Oh, so you do recognize the big voice. All right. Hey. Let me start by saying I have a lot of grievances with the... No, I don't. There's a few things we got to get out of the way first, so you know what I'm going to do. Let me begin with people who owe SAE things. You have taken things that do not belong to you, and you must return them or you will pay. And that's money that could go towards more car stuff. So the good news is it went from being a long list to a very short list. Are there representatives from École Polytechnique Montreal here? Well, I know that we all have feelings about it, but is there anybody here from that team? Oh, I am really blind, aren't I? And I'm wearing my own glasses this year. It's like, I don't know what I'm doing. Okay, where's your energy meter? I see you pointing at team members, but are you sure it's in G2? The people in G2 don't think it's in G2. Okay, as much as I would love to have you all here with me, can you send someone over to G2 to try and resolve that? I don't do energy meters, I relay messages. They don't trust me with electrical equipment, I break things. This microphone is the most expensive thing they let me touch. Okay, let's go to the other electronic thing. Are there representatives from Virginia Tech here? Look, Vatek, we've been friends for a long time, so it's not personal, it's just business. Vatek? Vatek. Going once? All right. I want one of you to go back and check your car. You still have our transponder. I will let you know that any lost or stolen transponders not returned by the Saturday of the competition deadline shall be charged to the university at the rate of... How many of you remember this from last year? What do you got? $1,000 per transponder. So I know that buys some Hoosiers. So get that thing off your car, get it back to SAE, all right? So energy meter, transponder. We good? Okay. Now comes the time I dread, because I have to lift things and talk about them. Let's start with easy things. How many of you were unable to get into your roller cart or unable to lock your roller cart at some point this week? I have a set of keys, which, given the relatively low quality of the keys, I believe belong to a tool chest. Anybody? 2 purple, 1 black. They're 2 different key codes. Nobody's locked out. You in the back? That's you? We got a big winner? He's coming under the tent. He's coming around. He's rounding third base. He's running, he's running, he's running. Is he going to find the gap? There he is. Come on, make your way through. It's the Formula SAE obstacle course. Georgia Tech, our first big winner. All right, let's go to the box. Oh, I love presents, and they're gift wrapped for me. It's a nice OGO bag, so hopefully there's a fancy helmet inside. I need, one of mine's out of specs, so what do we got? Oh, it's really crusty. Okay. Well, I can't win them all. All right, I got a Bell helmet. Somebody has been doing a lot of autocrossing. This has SCCA solo stickers back to 2015, so you're pretty close to the end of life of this thing. Is someone missing a Bell helmet? Size medium, so it definitely won't fit my dome. Black Bell helmet and an OGO bag. Going once, going twice, sold to the we have to store it pile. Please don't do this to me already. Okay, that one's off. See, this one I can use. I always make jokes about I can use this for my Lemons car, but this one I could really use for my Lemons car. Some of you left this at, oh, so your hand was up before I even got the thing answered. You're so excited. Are you sure this is you? It was at E-Tech. I think we got a winner. I didn't even get to talk about this. I'll make you a deal. In one bin, there's 2 sets of multi-row connectors. What multi-row connectors are they? It would be the end near the hinge, so yeah, top row. Top row, right side. RS-232, we got DB9s, big winner! Now, listen, this next one is slightly less high-tech. This is the least reliable part of Harbor Freight jack stands. This might be a recalled Harbor Freight jack stand, judging by the age of it. Who lost half of a jack stand? I got a hand, but I don't think you meant it. No, you didn't. You don't want this, do you? Okay. Quick note, by the way, don't leave metal stuff. We actually don't have a good capacity for disposing of metal on site, so if you have broken tents, broken chairs, grills that you don't want, I understand that it's a lot easier to leave them here for you, but it's really hard for you to leave them here for us. Okay? So pack up your stuff when you leave, take it all off site. Cool? All right, jack stand away. Ooh, it's Lenovo. I have a Lenovo thing. It's a Surface kind of holder thing, and there's a stylus in it. Lenovo thing with a stylus. Okay, people standing up just to get some air. Oh, we got a mover. Is this you? No, no, no. Okay, false hope. Oh, we got a winner! Illinois? Illinois. All right. I got another laptop bag. Laptop bag 2. Foamy Boogaloo. Nope. This one has no stylus in it. No? Nobody? All right. Hard fail. Hey, this one is actually, I know who this is because there's, I think, a school name written in here. Is this Northwestern? Okay, so I saw some people here with this Nevada hat. Is this somebody's hat with Nevada and some mountains on it and egregious sweat stains? And I don't put clothes on anymore because you all are stinky. Not really, but this is a hat that I don't want to wear, so. There's also a very wet Hoosier notebook. So basically the winner is the hat. No hat? No hat. Okay, next one. Another hat. You're not seating this thing full of stuff for me to wear, are you? Okay, good. I believe this belongs to somebody from the University of Michigan at Ann Arbor. The university has very strong branding. I'm going to leave it on the podium if you're not careful. Yeah? You're going to grab it? Am I going to frisbee it? All right, Michigan. We'll pass that out the back. Ooh, cool pullover. Got like a nice Nike Pro pullover windbreaker. Okay, cool. Nice Nike Pro windbreaker pullover thing. Yes? No? Okay, quick question. And this is like, because we're friends. It's a little warm in here. I wanted to dress up for you to look nice, but I'm kind of a little warm. Can I drop the sport coat? Thank you. Okay. This is totally not my color and also wouldn't only fit on one of my arms. Puma. Teal Puma. No. I heard some O's. Do we know whose it is? No. Okay, cool. Oh, right. Yeah, this one I've been wondering about. So I'll make you a deal, because this is actually a nice piece of electrical equipment. This is a can adapter. So it's actually like kind of a nice piece of equipment. I'm not just going to give this one away, but if you think you left this behind, there is something written on the lid that I'm not going to say. If you can identify the words on the lid, when you come pick it up, you can come pick it up. Make sense? Cool. That one goes back in the special bin. One of you is not going to be able to do some analysis, it turns out. Ah, yes, random bag of stuff. So I have a scrap pile at my workshop at home, and you know, this looks like the stuff I would leave behind. These may be cooling or suspension fittings, I have no idea. It's a giant, well, it's not a giant, because I can hold it. It's a bag of metal. Random bag of metal. Hey, we got a winner. UW. Are these your fittings? Oh. I feel like The best part is it's his home team that's booing him. Oh, well, this one is just swag that somebody left behind. It's a large Hoosier t-shirt. Did you legitimately get a t-shirt from the fine folks at Hoosier Tire who support us so much to this event and forget it? You took the gift they gave you and you dropped it on the ground. You would do this. Nobody's shirt? No, I'm not just going to give things away. That's not how this works. I thought about throwing it to the ground, but I'm not going to. This one I can explain, because those of you at home don't know that when I'm not up here making a scene of myself, I also weigh the cars at competition. So I get to see every team at some point during the event. And I asked about this piece of apparel, and calling it apparel is generous. It is a pink trucker hat with a bird and some sort of retro wave thing going on, and good on it. And it is my understanding that the team who made this, and I don't remember who you are, gives this out to the person who can successfully back up their trailer. So I know it belongs to one of you. Are you still here for the good hat? Oh. I briefly thought about wearing this when I saw it in the bin, but then I felt that like it was a plant, so that one's going to go back in the bin. Here we are to the dirty head sock portion of the event. Dirty head sock. How many? Okay, I don't know where this was left, but I feel bad holding it. Is this your dirty head sock? I see someone from Wisconsin getting up. Is this yours? No, okay, great. All right. I've got a Nike bag of some sort. Nike bag. Now I gotta ask, because I've been burned once before by somebody in a purple shirt. Is this actually your? It's actually his thing. I have a thermo flask with the words are hard, with what looks like a homemade logo on it. Thermo flask, homemade logo. Are thermo flasks nice? Okay, good. Well, it's a very nice flask. I hope you get it back. If it's yours at home, please let us know. I have a Contigo from our good friends at Bosch. Did you lose a Bosch Contigo? So it's a slightly less nice bottle with a slightly more professionally applied logo. No? Bosch? Once, twice, out. Continuing the trend of vessels for storing water, this is not the Cool Stanley, because I know there's like the Cool Stanley. This is not the Cool Stanley. Silver Stanley, cool one, not cool one. Is this your Stanley? No. Boo. Okay. I have two different types of gloves. One is for when things are spicy one way. One is for when things are spicy a different way. Did you forget your spicy oven mitts? Well, really, I think it's just one spicy oven mitt. That said, it's 2023 certified. So if you need one size 7 left-hand high-temp glove, there you go. Ooh, this has a note. Oh, wait, is that your spicy glove? Sorry, are they right? All right, Washington, you're on very thin ice. UW, you're killing me. All right. Oh, this one is great. I love it because it's like personal ads. The note reads, "Pretty sure we borrowed this from you guys, Formula Electric at Berkeley. I don't know if you guys means another team and they just left it. I don't know if you guys means SAE. Is this somebody's Klein Tools meter that you lent out to Formula at Berkeley?" Yeah, it's a Klein Tools thing. Of course it's orange. Oh, we got a winner. So who You're not sure. Hi, not sure. I'm Alton. No? Okay. Hold on. Wait. Is this also? No, this is a WaveTech meter man. WaveTech meter man. Okay. Nobody lost meters? You're going home with all your testing equipment? That's awesome. Ah, another spicy box. So this one was borrowed by Cal Poly San Luis Obispo. They borrowed it from someone, didn't remember who they borrowed it from, brought it to the announcer's table with the terminals uncovered, and just said, we forgot. So did any of you lend Cal Poly Slow a battery, an LV battery? If you lent an LV battery to Cal Poly San Luis Obispo, we have it. Please come get it. Well, this one has a name in it, so it's really easy. Northwestern, are you still here? Northwestern is maybe here, but this is Northwestern's thing. Northwestern, this is your thing. Are you from Northwestern? Okay, cool. Hey, all right. I think it's part of your tech inspection report, but I think it's a blank page, so at least you get the folder back. Small victories. One, and exactly one, wrist restraint. It is a DJ, so it's probably, is that karting wrist restraint? It's a wrist restraint. Back in the box. Oh yeah, the dangerous thing you shouldn't be flying with. So some of you drove here with this extremely off-brand multi-tool. Extremely off-brand credit card multi-tool that will definitely get you stopped by TSA. Is this any of you? Good, don't travel home with sharp things. Okay, we've got, I don't know what system this is. Connector to connector. I don't like that these both have positive ends on them. So there's some sort of presentation adapter that makes me sad. Is this your make me sad presentation adapter? Good, don't claim this as it's bad electrical safety. This is a USB to RS-232 adapter. It's pink. It has a brand on it. If you remember which one it is this yours? Okay. Mobile charger with extremely dirty pocket juice battery pack. Is this your charger with pocket juice battery pack? Initially, I was going to give everyone a lot of credit, but we lost a lot of things this year. This looks like... Okay, there's a lot of stuff on this. So it looks like a closeout plate. It has some signatures. It has a frowny face, and it says, "On God," and then I can't read the next word. But I know that this belongs to a Zoomer. Carnegie Mellon, come get your stuff. Okay. Next, blockout plug for the Amphenol connectors that several of you asked me to call for. No? Service plug, safety plug, R plug. A whole variety of off-brand electrical tools and wrenches that were definitely left at EV Tech that I'm dropping because there's so many of them. Did any of you leave tools behind at EV Tech? The folks at EV Tech really asked me to return them. They don't want them either. It's some snippers, some end cutters, some side cutters, some all kinds of stuff. All right, it's getting hot in here. We're going to move along. It's fine. A rod end. This is like the IC event where people leave me various suspension parts. I thought you were better than this. Rod end, rod end, rod end. Evan, not only do I have your safety goggles, they were at the table so long and I got bored that I fixed them. So Evan, I have repaired your safety goggles. Come get your freshly repaired PPE. These are just normal goggles. Normal goggles? All right. Did anybody lose a lens cap for a Tamron lens? Did anybody lose an empty Beats case? This one's been here a while. I don't think we're getting this one. One kind of, I don't want to hold it, earbud. Oh, come on, you come look at it. You can even hold it, I don't want to. Has this been in your ear? I'll test. That's your phone. If that doesn't restore your faith in the universe, I don't know what does. Someone was being very mean and they left me a hair clip. That's not nice. Is this your hair clip? Do you have long flowing hair and just want to show it off? Where's Evan? Okay. You forgot that thing. One walkie-talkie. It's not really a walkie-talkie, it's a rugged radio. I joke a lot about I could use this for my Lemons car, but yeah, you look surprised. It's a blue rugged radio. Are you coming around? Is it Georgia Tech again? Okay, there's like 400 of you at the back. Come on up. Not all of them, please. Oh, by the way, while we're talking about not setting the entire team up, remember, what are we not going to do on the stage? We're not jumping on the stage. Is this your radio? It's your radio. How did you talk to your team all week? It's been there since like Wednesday. They have 3 other ones. There's their radio. All right, we got a what color is that? Gray. Oh God, it's warm. Yeti. A gray warm Yeti. Okay. Yes, the floor mat. I'm not going to lift this up. It's a box of like heavy rubber floor mat that I think you probably use to insulate things in hot work and charging. Did your team lose rubber floor mat to hot work and charging? No, it's black. It's going to Farmington Hills, Michigan. I think that kind of narrows it down. But I'm not going to judge. Okay. Anyway, we've got a whole bunch of fire extinguishers that I'm not going to read through. If your team lost a fire extinguisher at the end of the event, come up and see if yours is up here. They all have names on them. My final 2 are, then the last one, which I'm going to keep with me. The thing that looks like it came out of my drops pile. Is this your thing? It was left at Mechanical Tech, I think. Mech Tech, like an alignment plate? You're on like 4x108? No? Okay. A socket wrench. Who's running 13/16 fasteners? Nope. Okay, finally, the one that I really cannot explain how you lost. I mean, I've been doing formula for a long time. How do you lose a 6-foot carbon fiber tube? I cannot believe that you lost this and you didn't think to look for it. Do you know how long I've had to stare at this? Do you know how many times I've made the inanimate carbon rod we trust joke? Illinois, ladies and gentlemen. That's the ratchet. Turns out I was too quick on the ratchet. All right. I believe that ends that part of the entertainment. You may have noticed that there's something I didn't give back. I would like to congratulate you on being the first competition in my recollection where I have not had to announce impounded gear from Tech. Congratulations, Formula SAE EV 2024. You're the first. All right. Well, I've had my fun. Now, for right now, I'd like to introduce somebody else up here to say a few words before we get into some of the specialty awards. You've seen her around the event. We've talked to her over email. I'd like to introduce Kaylee Zindel, FSAE Program Manager, to say a little hello to you.
Thank you. I don't know how I'm supposed to follow him, seriously. Thank you. I am not one who usually likes to be in front of people, so. But it is my job, so I am happy to be up here to say thank you to all of you, coming out for the event, registering, challenging us every year. This competition obviously exists solely for you, and then also our sponsors. So, obviously, first let's give it up for Alton, I guess, because, he does a fabulous job stalling time for us. And I'm going to try to stall a little bit more because I actually do not have the results yet. First, let me thank you for coming. Welcome to the award ceremony. As this competition concludes, obviously on behalf of SAE International, all of our sponsors and our volunteers, we want to say thank you for coming. We recognize all of you for your hard work and dedication. And although many of you maybe not had what results you wanted, just making it here into the competition has been a huge success. This by far has been our most successful competition, our 11th year running, and we had 38 cars ready to take track by Endurance Day, so you should be proud of that. Additionally, we sold out all 75 spots before 1 minute. And then we had about another 30 teams on the registration list. So next year for 2025, we will be increasing the number of registrations. I'm not going to say a number just yet because I'm not sure what that number is going to be, but we have been throwing out 100. So I'm just going to tell you that. But to do that, I need you to tell all your alumni they need to come back. They need to start volunteering. And it's not just on site. It's for the document review process too. That is honestly the longest and the most tedious part for us, right? I mentioned volunteers. We've had over 400 throughout the course of this week on site helping us make this competition a success. I like to stand up here and say, yes, I'm the program manager, but honestly, this program, this competition does not happen without all those people. We are 100% a team as well, just like you guys are. So let's give a round of applause for all of our volunteers. Thank you. Additionally, obviously, competition does not happen without funding, resources. You know this very well, as you have to build a very expensive car and get your team here as well. So a huge thank you to all of our sponsors. Without both their monetary support as well as their people resources, this competition would not be what it is today either. I have quite a long list of sponsors. This year was also our highest, another record-breaking year for Formula SE Electric. We had 44 sponsors on site at competition or having support us in some manner. And the easiest thing always to do is just to list them alphabetically. So here we go. Altair, Analog Devices, ANSYS, Autodesk, Blue Origin, Bosch, BWI Group, Clemson, Cummins, E-Controls, FEV, Fiberglass, Ford, Garrett, GKN Automotive, GM, Haas, HF Sinclair, Honda, Hoosier Tire, Human Capital, Intercom, Linamar E. Lin, Magna, MathWorks, Multimatic, NCES, sorry, I gotta put glasses on, Nissan, Oshkosh, PACCAR, Polaris, Onshape, Relativity Space, Rivian, Roush, Schaeffler, SolidWorks, SpaceX, Stellantis, Stoke Space, Systems Protection, Tesla, and Volvo. So let's give all of our sponsors definitely a round of applause. Sorry, if you get old, you have to get the glasses out when you're reading. I have one more final announcement. I did talk to several of you throughout the week. You had asked me about EV workshop. You hadn't heard anything. Will we be doing that again? Yes, we will be having an EV workshop. There are some changes to it, however. Dates and details will be coming. Unfortunately, I do not have that right now. However, I do have at least the announcement that I can tell you where it will be located. And I'd like to invite Alba Colon up here. As we needed a venue, one of our sponsors, who not only is a past competitor and truly dedicated to this program, she has talked to her boss into Hendrick Motorsports and North Carolina hosting the EV workshop this year.
First of all, thank you, Katie, and thank you, SAE, for a great event. Like she said, I used to be where you are for 4 years, and after that I started to volunteer, and 20 plus something years later, I am still volunteering for the competition. So please consider that when you graduate. On behalf of Hendrick Motorsports, we are very proud and excited to be the host company for this year's Formula SAE EV workshop. I think that we are looking at late September or early October, and we are looking forward to showcase all our facilities, technology, and many other places around Charlotte, North Carolina. So I'm looking forward to seeing all of you very soon. Thank you.
We are very excited to be going to Hendrick Motorsport. I actually got to go there, a week ago now, right, Alba? I literally was just there a week ago to get the quick one-day tour, and it's going to be fabulous. I think you who are attending will enjoy for sure. So watch for that information coming out on the app. We just have to get the date nailed down, and then once we do, we'll be pushing all that out, and we'll open registration, and it'll be free like all of the previous years, so look for that information. And I think that's all from me, so I'm going to go ahead and give it back to Alton. Thanks, everyone.
Thank you, Kaylee. Thank you, Alba, and thank you, Hendrick. I really hope that you all look into those workshops. They're really an excellent training opportunity, a great way to build both depth and breadth in your knowledge, part of the great programming that SAE helps put on to help make education meaningful for all of you. Real quick question. How many of you in here are graduating this year, whether you're seniors, finishing up a degree elsewhere? Okay, we got a few, right? How many of you are going on to new, exciting, fun jobs you're excited about? I want you to do me a favor. I want you to pull out your cell phone for a second, okay? I'm going to send you to a website that I know you've been to before. If you are a senior, do me a kindness. I want you to go to FSAE Online. So first of all, I want to note that my wonderful volunteers at Scales are currently the headline photo, so shout out to the Scales folks. It looks like, actually, I think we're scaling last year's FEI car, so shout out to FEI. If you go into the second section under Engage, under Sponsorship Info, there is sign up as a volunteer, sign up as a technical report judge. Those are the two links I'd like you to consider. I promise that this event is just as much fun when you're on the other side of the ropes, when you're mentoring, when you're teaching, when you're giving back, as it is when you're on that side, when you're learning and benefiting from all of the opportunities that SAE provides. With the additional benefit that you get to sleep a little bit more, on average. Okay, you don't get to sleep a little bit more. I'm sorry, you don't get to sleep a little bit more. But there's a lot less stress because you're not competing for points. Just like Alba and I think a lot of the volunteers here, I really enjoyed my time and learned an immense amount from my time doing the Formula. And I've come back, this is my 16th year volunteering at the event, and I can't recommend enough that you come back and spend a couple of days or a week here in the summers with us, because it's really fun and it's meaningful. And I hope that you recognize that we have as much fun doing this as hopefully you have competing in this event. Okay? So do me a favor, check that website out and get signed up. All right. Speaking of people who have been contributing to Formula for a very long time, it's my pleasure to invite to the stage a gentleman who, in addition to an illustrious career in motorsports and engineering, has been a supporter of the Formula SAE program for quite some time. Michael Royce is here to present the Learn and Compete Awards. Oh, I apologize. We have a problem. We have a problem. I lied. I'm going to have to ask Mr. Royce, sorry, to hold on for a second. So we'll come back to the Learn and Compete Awards. Instead, I'm going to invite Austin Wooldridge from GM. Austin is a design release engineer for GMC Sierra EV. I believe Austin was a competitor at Wisconsin, right? So another FSAE alum, here to present GM's Everybody In Award.
Thank you very much, Austin. How y'all doing? Oh, hold it close. Okay. Hi. How's everyone going? I know everyone's very tired and wants to get out of here. It's very hot and everyone's smelly, and that's okay. So I'm going to go real quick, but also get into the award. My name is Austin Woldridge. I am a design release engineer, as Austin said, on the GMC Sierra EV. I am here this evening because I was told, not because I was told to, but because I want to be here. I credit the Formula SAE competition with getting me to where I am today, including getting my first job at General Motors. Without my participating on the University of Wisconsin racing team, I probably wouldn't be up here speaking to you today. I think I speak for more than 100 GM engineers that have volunteered at the competition this week in saying that Formula SAE produces some of the best talent in the world, full stop. The skills that you garner from the Formula Electric competition set you all up incredibly well for a fruitful career wherever you may find yourself. The grit, dedication, and tenacity that you all displayed this week and throughout the year is palpable, and this is the type of energy that General Motors needs to develop its next generation of world-class products and services. So congratulations to you all for showing up this week. I know this competition can have euphoric highs and devastating lows, but you will learn valuable lessons everywhere that you turn. With that, enough of my yapping, let's give away an award. As I've said, GM finds great value in the Formula Electric competition and all of you that participate. So much so that we developed the Everybody In Award, the prize for which is free registration to next year's comp. The goal of the award is to make a meaningful connection with students and teams while also sharing the values of our Everybody In campaign, including safety, electrification, and social impact through inclusion. We envision that the team who receives the award demonstrates the following core behaviors: a pervasive safety culture, a commitment to reducing emissions by tackling unique challenges presented by developing an electric propulsion system, and persistent good faith efforts to be inclusive of everyone in and around the Formula SAE community. This year's winning team's goals and motivations are clear. They want to equip their members with both the technical and interpersonal skills it takes to be successful within the team, as well as a young professional. This team also embodies a safety culture in everything that they do by maintaining 3 senior level safety rules that help enforce the required training for all team members, implementation of safety guidelines and processes that cover everything from disposal of scrap materials to general safety habits. This team is dedicated to an electric propulsion system, which is evident in the team's creation. The foundation of a new team aligns with their organizational goals, providing an environment where team members can develop skills they need to succeed in an industry which advances the EV industry. And finally, one of the team's priorities is breaking down barriers to entry and engaging with their university community. The team facilitates new members' engagement through training and have incorporated students from over 15 different departments at their campus. As a part of their team merger, creating an inclusive culture was a priority, which includes a reporting structure to address inappropriate behaviors and to keep their team a welcoming environment for any student. It is for these reasons that it's my pleasure to announce that the winner of the 2024 Everybody In Award at Formula Electric is the University of Waterloo.
Oh, wait. No, you're
Congratulations, Waterloo. Thank you, Austin, and thank you, General Motors. Oh, you got some to give out. A little bit of swag. Who wants some swag? All right. All right. We've got GM hats flying all over. Yes. I hope you've noticed, it's hard to see over the live stream. There are hats everywhere. It's pandemonium. This event wouldn't be possible without the enthusiasm of the students, without the passion of the folks working the event, and without the support of our volunteers. So we really appreciate everyone. Up next, I'd like to present an award from one of our other sponsors. I'll note that there's a set of trophies on this stage that looks a little bit different than the others, and those are the hardware for the Cummins Innovation Award. Now, on behalf of Cummins and Accelera by Cummins, I'm thrilled to be presenting this award. Cummins is a global leader in power technologies, and they're proud to be a sponsor of Formula SAE. Accelera by Cummins specifically focuses on advanced battery technologies, making them a perfect partner for this competition where innovation, sustainability, and teamwork are at the forefront. This year's competition truly pushed the boundaries in all three areas. You have all showcased incredible teamwork, tackled complex engineering challenges, and most importantly, kept sustainability and the future of electric power systems development in mind. Now, let's celebrate the winners of the Cummins Innovation Award. In third place, with this piston trophy, we celebrate the team from University of Calgary. As they're walking up, I'll tell you what they did. In developing a mobile app using LiDAR to map out the car in real time and provide a visual aid of how elements on the car interact with the airflow, they changed the game. This achievement combined cutting-edge technology with practical application. So in third place, congratulations to University of Calgary. Now the second place team did something really interesting. Replacing a traditional drivetrain with a custom designed planetary gear set is definitely a bold move. This achievement showcased their deep understanding of power transmission and their commitment to efficiency. The second place award in the Cummins Innovation Award goes to University of Guelph. Okay, if there's no one from Guelph here, we'll put the trophy in a box, we'll make sure it gets to him. This comes with cash, right? I forgot the cash award? I always forget that. See, I'm so obsessed by the trophies, I forget there's cash. So third place is $500, second place is $750, but the $1,000 top prize and the cool hardware goes to a team that used an off-board thermal management system as a brilliant example of thinking outside the box. Cooling a battery pack at near freezing temperatures presents many unique challenges, and their innovative approach in this area demonstrated exceptional problem-solving skills. And so, the first place award, $1,000 and a trophy, goes to San Jose State University. Thanks everyone, and thanks to Cummins, and congratulations to everyone who submitted. As a final note, on behalf of Garrett Motion, I'd like to say that Garrett Motion appreciates all the universities for their innovation and their differentiated ideas that contribute to the advancement of the EV technology in Formula SAE racing. To them, it was a difficult decision as the teams all submitted excellent ideas to improve their vehicle's performance. And so this year, they ended up with a tie, and they want to congratulate two university teams. The winners of the 2024 Garrett Powertrain Innovation Award are the University of Michigan, Ann Arbor, and Carnegie Mellon University, both of which for their innovations on pouch cell battery technology. The trophy and the money is in the mail, I'm sure. Okay. Okay, now that I've false started twice, now to present the Learn and Compete Awards, someone who has been instrumental to the growth and development of Formula SAE and other SAE-related programs. It's my pleasure to introduce Michael Royce.
Okay, a little bit of a background here. About 15 years ago, a gentleman called William Kimberley, who was the editor of Racetech magazine, got a hold of me and my wife Suzanne and said, please use your years of experience with Formula SAE and in professional motorsport. And for those of you who never met Suzanne, she was a chief scrutineer for Formula One in this country for 35 years. Anyway, William asked us to put together a book to help you guys and gals out. So we twisted the arm of about a dozen of our friends, many of whom were senior design judges, and came up with the first edition of Learn and Compete. And it came out, was published in 2012. Well, it ran out, they ran out of it, so William Sahila talked to me and Suzanne about 5 years ago and said, you need to do a second edition. So the second edition, which includes 17 new chapters and over 200 new pages and now is in 2 volumes, came out, in fact, 2 years ago at Formula Student UK. Starting last year, I have donated at Formula Hybrid, at the IC event a month ago, and here a number of copies. So what I'm trying to do is that I'm donating to those teams that I deem to be deserving of some assistance in their efforts to improve their performance at the competition. So it's for guys and gals who really need a leg up. One of the criteria is, since I've already paid for the damn books, and being a cheap Yorkshireman, damned if I'm going to pay the postage to mail them to you, so you've got to be here to pick it up. Okay. The first team I'm going to call up is anybody here from Car 241 IIT, Illinois Institute of Technology? Okay, we missed them. Drexel, Car 254. Missouri Science and Technology, Car 264. One of the other reasons for insisting that you pick it up here is that then it shows that you are supporting the people, in fact, they get the silverware. So it's a two-way street. Car 248, Northwestern. I saw Northwestern picking up stuff from... Come on up, Northwestern. For those of you who haven't got it, it's available from the SAE bookstore. So go online and get it. It's got stuff in there all the way from team organization and project management through design, superb chapter by Mike O'Neill on brake systems, through to chapters by C. Fox on some tips on building cars, all the way through to at the competition. Okay, now go for number 2, Binghamton, car 253. Anybody from Binghamton? Car 278, University of California, Santa Barbara. 269, Windsor, University of Windsor. University of Guelph, I know they need help. They're here, aren't they? Guelph? Come on, Guelph. Own up. Didn't they just get an award for something? Brigham Young. Car 280. Now, you guys used to be at Formula Hybrid, so get your act together again, okay? Car 284, USC. They're a bit ashamed to be here. Oh dear. Car 226, University of California, Santa Cruz. Another new team. Santa Cruz, okay. University of Cincinnati, car 291. University of Ontario Institute of Technology, car 298. Olin College of Engineering. Olin from Massachusetts. Rutgers, car 234. Toronto Metropolitan, car 224. Okay, car 249, Centro Universitario da FEI, from Brazil, I believe. Anybody from Brazil? Okay, well done, guys. Okay, I'm going to leave it at that.
All right. I have good news. I stalled long enough. I hold in my hand important documents. And here to help me out with handing out the actual hardware. I do it, I make her do it because it's fun for me. No. I've been helping Kaylee out with this for a while, and it's great to be up here on stage with you, so. Okay. Let's give out some hardware. I have the awards. And we're going to start with the Business Presentation Award, which was sponsored by Haas. And hopefully here to help me hand out this award, I'm looking towards the crowd, would be Samuel Dobry, who's a mechanical design engineer at Haas. Samuel, you still here? Okay. Unfortunately, the nature of these things is sometimes this happens. So, sorry that Samuel couldn't be here to join us, but we have scores for the presentation award. The presentation event involves teams defending a business case around their vehicle, how they designed it, how they would manufacture it, and a specific scenario around how they might justify changes in powertrain to a board of directors. And in this year, students made virtual presentations and then also made presentations on site. And so from those presentations, we've arrived at a top 3 teams. In third place, in the business presentation sponsored by Haas, we have the University of Washington. All right. Now, in second place in the presentation event, we have McGill University.
I saw them waiting in the wings. I was ready to call them up.
All right, come on up. And in first place, and I'm putting my backpack because there was a late lost and found arrival. In the presentation event, we have the team from Kennesaw State University. You get the trophy, you get the points, and your ESO gets their backpack back. This is a one-time only event. All right, great job, everybody. Yep. Okay. Up next in our static events, because this event is an engineering competition, and so we ask teams both to compete on the track, but also to justify the design decisions they made. And one of the ways we do this is we ask them to make evaluations and justifications with respect to the cost of their vehicles. And so teams submit a report where they cost out the production of a vehicle that would reflect the prototypes they've built here, and then they're audited for their knowledge of cost in manufacturing here on site. And so the cost award in third place goes to University Laval. They're coming around the outside. I see them coming. Now they're coming in this door. Okay. Let's make space for Laval. I know it's tight in here. Yep. All right. In second place in cost, and the cost event being both a combination of the cost of the vehicle and the student's knowledge in cost and manufacturing and the quality of their report, we have San Jose State University. All right, congratulations. But your overall winner in cost had both a cost-effective vehicle and the knowledge to prepare a report and justify it. Your overall winner in cost for Formula SAE Electric 2024 is Kennesaw State University. Now, as they return to their seats, how many of you went to the design finals review session? All right, well, that's a little disappointing. I want to encourage you next year, come to that review, hear what the design judges have to say. They discuss the finalists, they discuss the progress of this event as a whole. It's a really important part of learning. If you didn't see it here, can they watch it on the live stream? They're pointing at the camera. You can watch it on the live stream later, so watch it when you get home and then stop watching once I start talking. Okay, well in this case, I guess it's time to repeat the overall winners in the design event. Their cars are parked outside if you want to see them on the way out. In third place in the design event, we have the University of Michigan, Ann Arbor. Now, for those not familiar with the event, the design event involves 2 rounds. First, every team meets a panel of judges who ask them questions about decisions they made around the design of their vehicle and the documentation and the research and the engineering supporting those decisions. And then a round of finalists all go out on Friday night to be judged collectively by another round of judges. From those finalists, we also have our second place finisher, École Polytechnique Montreal. However, the design event is not just about the car that students bring to competition, it's about their knowledge of engineering in general and their knowledge of why they made the decisions they did. And so when faced with a competitive field of strong vehicles and brilliant engineers, the design judges came to the conclusion that one team deserved first place overall. And that team was McGill University. Sorry. So, our static events were on Thursday and a little bit on Friday. But on Friday, we had the first of our dynamic events, where students take the vehicles that they prepared after they've passed through various inspections, and they took them to the course. And the first of the events that they competed in was an acceleration event, testing the raw power of the vehicle and the ability to put that power to the ground through effective suspension design. The Acceleration Award is sponsored by Stellantis, and perhaps you saw one of their vehicles testing the timing at the acceleration run. In third place in the acceleration event presented by Stellantis, we have the Rochester Institute of Technology. In second place in acceleration, we have Oregon State University. Their Excel run was much faster. Sorry, it's a long walk. I'm sorry. Just push me. But those cars were fast, but there was one car that was a little bit faster. Your overall winner in acceleration, it's always weird to see the full name spelled out. It's the Georgia Institute of Technology, it's Georgia Tech. Please watch the table. There's a lot of you. Now, in addition to accelerating the straight line, it's really important that a car like a Formula car, which is designed for autocross, has good lateral acceleration. The way we test that is with a skid pad event. We have teams make 2 laps in one direction around a figure-of-8 course and 2 laps in the other direction around the figure-of-8 course, and then we pull a cone and they drive off the course, hopefully. So, the Skid Pad Award this year is sponsored by Onshape, a professional cloud-based CAD and PDM design platform free to student teams. In third place in Skid Pad, we have the University of Washington. One of the exciting features about EVs is the new potentials for integrating powertrain into turning and rotating the vehicle during the skid pad event. In second place in the skid pad event, we have Cornell University. Rocking the Formula socks. However, one team was just a little bit faster than the rest. Our overall winner in skid pad is Georgia Tech. Great job. Now, on Friday, we asked the teams to put it all together. These cars are designed and meant to be vehicles for competing in autocross events. And so we asked the teams to take the vehicles they've designed and built and tuned and perfected and take it out to an autocross course and compete for the fastest time. An autocross event asks drivers to do a fast lap without hitting cones in a course laid out that features corners of different lengths, different radii, straights, slaloms, and the like. And in the autocross, 3 teams rose to the top. In third place, we have the University of Illinois, Urbana-Champaign. I wasn't dabbing, sorry. I would never dab. In second place in autocross, we have the University of Wisconsin at Madison. Now, if you're new to Formula SAE, you may know that the autocross times and the autocross results help seed our run order for endurance. So you might already have a guess who the overall winner in autocross is. Your overall winner for the autocross event at Formula SAE Electric 2024, the Georgia Institute of Technology. And that brings us to today. So, the events on Saturday are broken into 2 events that occur simultaneously. So the students here know this, but for the benefit of those of you at home, on Saturdays we ask teams to complete 22 laps of our course, 14 kilometers, sometimes I forget. And in that event, we test both speed and efficiency. And so, it's longer than 14 kilometers, sorry. First, the awards for the endurance part of the event. The endurance event, I apologize. Actually, give me a moment. I don't often do this. I have to apologize to our friends at Magna. The autocross event was sponsored by Magna. Their banners were out there. I saw the trophies. I apologize. Thank you to Magna for sponsoring the autocross event. It's been a long week for everyone. Okay. Both the endurance and the efficiency awards are sponsored by our friends at Ford. And so in the endurance event, we had 38 teams attempt the endurance run, eligible for the endurance run. Of those teams, 3 of them rose to the top. In third place in the endurance event, we have San Jose State University. In second place in endurance, we have RIT, the Rochester Institute of Technology. Got to work on our packaging engineering. Now, the endurance event is a big challenge. It requires going the distance. It requires a driver change. It requires restarting the vehicle. It requires fast, precise driving to minimize penalties. And out of all the teams who attempted the endurance run, one team rose to the top. And that team is the University of Washington. But that part about going fast and going the distance, it's only half of the equation. Because this event is also about designing vehicles that use energy efficiently, that take the capacity of the battery, of the accumulator, and put it to the road as efficiently as possible and recover as much energy as possible during the endurance run. And so after teams have completed the endurance run, or the portion of the endurance run they can, we measure how much energy they used, and we calculate winners in the energy efficiency event. The energy efficiency event is also sponsored by Ford, and again, 3 teams rose to the top. In third place in efficiency, we have Western University. In second place in efficiency, we have the University of Akron. Okay. We're going to make sure that Akron gets their trophy, which leads me to the overall winner. The most efficient vehicle in the endurance run came from Cornell University. Great job, Cornell. And great job, everybody.
Now, it's not often
I get special notes before announcing awards, but I've been asked to note, and it's very exciting, that Formula SAE Electric was more competitive this year than ever. Going into endurance, just 38 points separated the top 11 teams. That's 38 points out of 1,000 overall, for those of you at home. In the final results, the top 4 teams are separated by 9 points. Every point counts. The Spirit of Excellence Overall Award takes all of the awards that we've mentioned, the static awards, the business presentation, the cost evaluation, the design, the acceleration, the skid pad, the autocross, the endurance, and the efficiency, and it combines them to present an award that represents a team and a vehicle that is well-rounded, which is the goal of this educational program, building better engineers. And so, we have 10 awards for the Spirit of Excellence overall. In 10th place, we have the National University of Singapore. Sorry about the mic. Now, in 9th place overall, we have another team that performed well across a variety of events. That team in 9th place is the University of Toronto. But while we're waiting, there we go. As we're getting through these final awards, a couple of reminders. So you're all sitting on, well, not all of you are sitting, but some of you are sitting on chairs. us a favor. Fold that chair up, stack it at the back of the tent. Where are you going to bring it? Back of the tent. All right, good. Thank you. I was asked to Okay. I promised I would say all these. Your paddocks. Your paddocks. Have you enjoyed hearing me talk to you about your paddocks all week? You have, really? Okay, well, I'll do it one more time. Your paddocks. We are very lucky to have a lovely facility here at MIS. One of the things that makes that possible is that we leave it the way we found it. Please, with your paddocks, make sure they are clean. That means what you came with is what you leave with. It's like camping, even though it's on pavement and you brought really weird tents. Everything you brought in, bring it out. Make sure your paddocks are clean before you leave. Your cooperation in this matter is very much appreciated. I almost lost my place. In 7th place overall, we have the University of Washington. No. You all right? Quick friendly request. Please don't use the speakers as flotation devices. Okay. A couple of other awards notes. If you need a box for your award, if you're flying on an airplane, if you're concerned about it getting dented in shipping, we do have boxes for awards. If you get an award, we can put it in a box for you, or you can put it in a box yourself. Come look by the stage after the award ceremony. Okay. In 6th place overall, we have Cornell University. couple of other notes. Oops, sorry. A couple of other notes. The official results will be posted next week. So, do you have the app on your phones? All right. Well, in that case, it's time to tell you who came in 5th place overall. The 5th place winner in the Spirit of Excellence Overall Award is San Jose State University. As San Jose State's moving back, quick note, the registration for the 2025 season, because the 2025 season starts tomorrow. The 2025 season registration will be, 1 week. It starts in 1 week, I've been told. Anyway, registration for the 2025 season will be this fall. Please watch the FSAE mobile app for updates on that. In 4th place overall, we have Georgia Tech, the Georgia Institute of Technology. And now we come to the top 3. The Spirit of Excellence Overall Award is sponsored by SAE International, and they've been putting this event on for quite some time. And so we thank SAE for all the hard work they do putting this together. In third place overall, we have the University of Wisconsin-Madison. As a quick note, if your team is here and you want your energy meter data, if you have a thumb drive, you can come here at the end of the award ceremony to get a copy of your energy meter data for the event. Sound good? I'm definitely not playing for time until the aisle clears. Okay. In second place overall, École Polytechnique Montreal. Now, before I announce the overall winner, this one is my most important announcement all year, so I hope you'll humor me. Every year I say this, and every year I mean it more and more. It's a lot of fun to come here during the summer for our big, crazy family reunion for these Formula SAE events, okay? We look forward to seeing each and every one of you back here next year for more Formula SAE, whether it's as a competitor or a volunteer or a sponsor. And that means we want you to get home safely, okay? Take breaks, drive safe, stay within your limits. We want to see you here safe and sound next year. You got me? All right. Well, in that case, there's just one more really big piece of silverware for us to give away. And this is the award for the Spirit of Excellence overall winner. Okay, now I'm not playing for time. I just misshuffled my papers. The overall winner for Formula SAE Electric in 2024 is Rochester Institute of Technology. That's all we've got. Thank you so much. Congratulations, RIT. Congratulations, everyone. Fold your chairs back in the tent. We'll see you in 2025.